So as it is, it's Introduce a Girl to Engineering Day today. So she's going to be introduced to all of the world of crash safety. So in putting this together, this talk together today, I was having a difficulty of all the projects that we had done in crash safety, and I only got to talk for 30 minutes. So I could go on and on about crash safety. I really enjoy what I do. So in this time at the Crash Safety Center, I know some of you may not be familiar with what we do in the Crash Safety Center all the time. We're down there in the basement of the Mott building, kind of hiding out. Sometimes we have our blinds drawn because we're doing confidential work and we can't always share it. So just to give you a little overview, one of the things in our logo, the Crash Safety Center talks about university, industry, and community. We are the only crash safety facility in the world that we know of that brings crash safety to the undergraduates, as well as we have our doors open to the community. We have many different researchers within the university, including myself, but across all different disciplines, including industrial engineering, as well as physics, mechanical engineering. We all have done some type of work in the center. So in the university standpoint, as far as bringing this to the undergraduates, bringing crash safety to the undergraduates, we have 3 classes that are hands-on in the Crash Safety Center. The Newtonian Mechanics, the Phys 115, with Dan Ludwigson being the PI, getting an NSF grant and a Keen grant to develop crash safety into Newtonian physics, as well as Professor Tavicoli working in collision analysis, and Pat Atkinson in the area of occupant protection. So those 2 classes are at the 500 level, but the seniors, of course, are allowed to take them as well. We have worked with many different industry partners. So we do research as well as testing. Sometimes we just do testing for an industry. They need something done. We also bring training. We had a company come in fact, they're not in here, a company from Taiwan that was just getting into crash safety for child seats, and so they wanted to know how to do the testing. So they came in, they ran the tests. We were able to bring them in hands-on and show them step by step how the tests go. So we educate as well as in the industry and working with our industry partners. But as I said, we like to open the doors to the community. We've had everything in there from Boy Scouts to K through 12 education. We go out to them as well. Terry and I had done some projects in looking at range of motion of children's neck, their head and neck complex, so that we could look at it with respect to the crash test dummies, or crash test dummies. And the one thing I learned there, so at one point where their kids are getting measured to look at their range of motion, we did a little show and tell about crash safety, talked to them about what kind of child seat they should be in, and we brought a crash test dummy with us. So in that, the kids, this was kindergartners, the kindergartners were looking and they thought it was really cute and they thought it looked like a doll. And I was trying to explain how we use them to help out. So on the back of their head, you take out the back skull cap and you can see the accelerometer that we can put in its head to measure head acceleration. When I went to go take the back of the head off, one girl went screaming and crying out of the room. She really thought I was hurting him. So then I learned at about 2nd grade, that's really cool, you know, and you start crashing things. So I've learned through all this is about 7 years old is that the tipping point between don't take the back of the head off to, yeah, that's really cool. So the community, it really has been fun working with that. So not only with light, one of the things we have up here is Ann Arbor Skyline High School. It's a program I just want to talk about real quick. About 3 years ago, they decided at Skyline High School that every sophomore, no matter if you were honors or AP, or if you were special needs, that you were going to take physics. So sophomores in high school taking physics. So they decided to wrap it all around crash safety. So they called us here. They saw that we had a crash safety center. And even though UMTRI, University of Michigan Traffic Research Institute, is right there on their back door, they gave us a call. And since it was education and physics, the first thing I did was call Dan Ludwigson and brought him in. But we go down there every year to introduce crash safety and how crash safety and Newtonian physics really are what you do every day. Well, hopefully you don't crash every day, but what you do in your car every day, and you might see that it very much relates to the physics in real life. So it's really been a fun program to be involved with. Uh-oh. There we go. Well, okay, so it broke off here. So in all this, talk about all the research that we've done and all the projects I've done, I thought I'd talk a little bit about what, if you're taking your family trip, what's trending in crash safety? Now the OEMs do a really good job of taking and designing the vehicle itself for crash safety. They put the airbags, seat belts, instrument panels, seats, the vehicle structure. Everything is designed to keep us safe. They want to get the 5-star ratings on their vehicles when they're crash tested. And they're good at that. And if we go through, we do our homework, we buy our car, you get a good car, you say, okay, I went and I bought the best car I could, let's go off on the family trip. Well, there's still more that you can do in that. So not only, again, the seats, the seat belts, airbags that they've done in testing, the amount of testing and money that goes into crash safety on the OEM side, those are focused for the adults. Most of the Federal Motor Vehicle Safety Standards all are focused on the 50th percentile male dummy. He's about 170 pounds, he's about 5'10". So a lot of us are not that. So there's more work too that can be done and that are focused with the OEMs. But we have our other passengers. So we have our kids in the car, our dogs. Actually, we're going to talk a little bit about that and what we're doing with some things with pet safety. But also there's an interesting area right now that's going on with transporting your children on airplanes. So I'm going to also touch on that in a project that we're doing there. So on the child seat side is the Federal Motor Vehicle Safety Standard. It's FMVSS 213. And it's focused on child seats. Everything in the design of the child seat, from the flammability of the materials to just recently, they added the fact, this was 2006, they added the fact that there's pass-fail criteria in frontal impacts on child seats in an actual collision. Before 2006, a child seat was out there. It did not have any type of pass-fail criteria for buying a child seat. I was shocked. I have 2 kids. They're in their 20s. Well, one's in his 20s, the other's 17. So of course, you know, engineer I am and the good mom I am, and go out and buy the first child seat. And I said, I want to get the best child seat out there. Well, at that time, there was no dynamic standard. There was no federal standard that they had to pass to say, yes, the risk of injury of the child in that seat was going to be minimized by buying that seat. So it wasn't until 2006 then they had to start passing a frontal impact test of 30 miles an hour. So that test looks something like this. We do conduct the test here in the Crash Safety Center. So that's a properly installed child seat. He's in there, you can see he's doing the right thing. It keeps him in the seat. You've got a 5-point harness, puts all the loads onto his torso. And actually, there we go. Let's get it zoomed in there. So you can see it, that's working correctly. This test would have passed the criteria. So the criteria does look at both instrumentation in the head as well as the chest. Now, Pat Atkinson was, Dr. Atkinson, he was at a safety check. So he's a certified child seat checker as well as Teresa Atkinson. I used to be. Cheryl is, so I'm a former certified person. But he was at one of the checks and someone came in that had their child only in one of the harnesses. So only one of the arms. So that was the best I could do. The harness was all jammed in there. So I figured I'll put it on one arm. It's better than nothing. Well, so in his class, they went and they decided to test it. So this is what happens. Let me try to zoom that in again. We'll play it over. What happens if only one arm was in? In that case, you can see how the seatbelt digs into the arm. Now, crash test dummies are designed not to break. When they're, $100,000, the little guy here is about $60,000, we don't want them to break. We want them to stay intact and be able to test over and over. So there is no instrumentation in the arm. There's really no way to say, yes, the arm could have been severed or something like that, but it is pretty severe. That having them in that child seat is a good thing, but you still have to have them properly in the child seat. And the child seat has to be properly in the car. So you've got two things that as a parent or caregiver, you got to check. So you got to make sure first the child seat gets right in the car, and then the child gets put into the child seat correctly. And not only that, now you got to figure out, do they have the right child seat? And by which laws of which states of which child seats you should be in, and how long you have to be in them. So there's a lot that goes into the crash safety and with respect to the child seats. So in all this, 2006, we finally got a frontal impact standard for child seats. And one of the cool things as an engineer, I kept thinking, it's really nice to have a child seat in side impact. If you're in a side impact in a vehicle, you can see here in the picture. So this is a crash test of a side impact barrier into the side of the car. And this is how the OEMs test for side impact integrity. In that, you're right next to that barrier. So the driver in this case, you got the barrier coming in and you've got the acceleration fields of the collision. If you're in a child seat, you get not only the protection that the OEMs have put into the doors with airbags and the door structures, you get the child seat. You've got this structure right next to you that can protect the child as well. Well, there is no side impact standard for child seats. And if you go buy a child seat, which is very interesting, it'll say all over the child seat, side impact tested, side impact protection. We passed the standards. And they're all over the child seats, even sometimes sewn right into the sides of them. Thing is, if you look at the small print, it says in-house standard. There is no government standard. So you don't know what they're doing. You don't know how they're testing it. But as a consumer, you go and you buy it and you think, oh, yeah. That's a good one, because me as the parent going out there, you're going to look at that child seat and say, yeah, that's the best one. They pass the standards. Well, all of them have to pass the federal standards if they're going to be sold in the United States, but there is no federal standard in side impact testing. So a little bit of the history, don't want to do that again. A little bit of the history of what has occurred now in side impact testing. So first of all, you had to ask, do we want to test the near side occupant, the one right next to the barrier getting hit? Or do we want to look at the far side occupant, the one that has the acceleration fields but don't have a door or pole coming in and hitting them directly on? So this is actually one of the tests in a child seat that's done just looking at the far side impact. So all you do is put it in the acceleration field. Does the child seat tip over? Does the kid come out? We can test that. And so in fact, when you go and you buy a Graco child seat, and it says it's been side impact tested, it's been far side impact tested, not near side impact tested. Now because of that, one of the things we did is we got together with one of our corporate partners is Doral Juvenile Group. They make child seats such as the Eddie Bauer, which was this one, Safety First, Costco child seats. And they said, we want to come up with something that looks at the near side occupant. We know there's a greater risk of injury if you're going to be in the near side. We want to be able to deal with this structure. What can we do to make it better to protect the child? So we came up with a test procedure with them. And in that case, I'm going to zoom in and see if I can get this to work right. It's going to start playing. You're going to see from the left is the door coming in. So with the on the deceleration sled, the child is sitting there down at the impact side, and he's just waiting. As on the deceleration sled coming in this case at 20 miles an hour, and the door comes in and impacts the child, getting that idea of the impact of the near side. Notice he came out of the picture because he's on a set of linear bearings. And just like in a side impact, you don't get hit and stay there. You get hit and you move out of the way. So we had to account for that in the test procedure. So let me play through that one more time. So he's sitting there on his seat, and the door comes in and impacts it. Now there's so many different kinds of doors out there and different structures from different vehicles. You have to make it generic so that you can at least test what's happening to the component of the child seat. So we did that. In this test, this is the frontal view in essence. So the door is going to come in from your left and impact the child. So you can see how that works out as well. When we ran this test, this is at 90 degrees. So the door is strictly right in line with the child. And it was working out great. There's a lot of things that we could learn as engineers from this, and Durrell Juvenile Group did. And there were some changes. One of the things in particular is you can see as the door comes in and as the head rotates, the wings do a lot of good in protecting the head. So a lot of work was done with the 90-degree impact. In the meantime, Takata, well, everybody's heard about Takata these days with airbags, but Takata in Japan is one of the largest sellers of child seats. They don't sell them here in the US. They've been talking about bringing them here. But they came up with a similar method, but it runs on what's called a high G sled. So in that case, now it's kind of deceiving watching this picture. Everything stays still. And instead of the door coming in and hitting the child and the door are on the same sled in essence. And you take and you accelerate, accelerate the main sled underneath it, and the child is actually staying still before the door comes in and hits it. It's hard to explain. I'm going to see if you can see it. Kind of watch the background a bit, and you can see how things are moving. So really, it's not the child moving. It's the door moving towards the child in this, and the child staying still. A little hard to explain. So, but another view of it, would love this view. You can look at down the track and see how the head then interacts with the door. You can see in this case, the wing wasn't quite big enough, and then the head left chalk marks here on the door. It's one of the reasons we chalk their faces so we can see the transfer of different parts of the body in different places in the vehicle. Now, we didn't run these tests. We don't have a high G sled. So some of the other testing that was going on in the meantime, Australian side impact is more like a near side impact. They run it just looking at the acceleration field, but they put a solid door next to it. So if it does tip over, it can hit the door. So it really isn't a true near side impact. European have been looking at different types of near side impact tests. They still can't decide between them what they want to do. One was called a swinging door, where the child would just sit there and then the door would come in and swing on a post. Problem is you got different velocities at different points on there, linear velocities, because of the swinging door. So that one was kind of the top one until engineers are saying, really isn't a good fit for what we want to do. So it ended up the National Transportation Safety Board, NHTSA, National Highway Traffic Safety Administration, decided, okay, we got to bring this all together. The consumer groups are angry that you can go out and you buy this child seat and everybody's saying they've got a standard and there is no standard. So we ended up working with them for 2.5 years in developing a standard that all industry could use. And in that case, the problem was they wanted to add a 10-degree angle. So not just the straight 90 degrees, they wanted a 10-degree angle. So in that case now our deceleration sled goes running down the track, and it has the child in the child seat on the sled itself as well. So the main sled, there we go. So the main sled stops because of the way the deceleration sled works. So the main sled stops, and the kid keeps going, laws of physics, and it impacts the door. Well, this was another issue that the industry was saying, well, wait a minute. If the door hits the child or the child hits the door, are they the same? Well, there were some things we had to make sure, such as the door needed to be stopped when the child hit the door, because you don't want those relative velocities. So we looked at that. We also looked at some issues that once you do hit the door doesn't move too much. And we get some play in it, but not much. But the engineering, the physics between the two tests were the same, and we could get the 10-degree angle. So this is that other shot. I like this shot. This is the one looking down the track. And so you can see the door come into play. It's being stopped on the regular decel sled, and the child moves in and hits the door. Now in this seat that we were testing at this time, this was an even flow seat, you can see the head then goes out of the wing area and does strike the door. One of the other interesting things, just to bring up some physics here, watch the dummy's head right here. It's moving forward and then it starts moving back. This was because of the 10-degree angle. And as the dummy was moving through this 10-degree angle, it had a vector of that acceleration in that forward direction because it's off on an angle. And it's making the head move forward. Right now, this standard is in it just went through the phase where they put in a notice of proposed rulemaking out to the industry. Then they get to send questions back or comments. They say, yes, we like that or don't like that or great idea or changes. The whole thing with this child's head nodding is a big issue. In order to run this test on a deceleration sled, we need to go 800 millimeters before the child hits the door. Because as I said, that door has to be stopped before we can hit it. Giving the head more time to move forward. In fact, with our 800 millimeters, as you saw, his head moves forward and it starts to move back. On the high G sled, and they run this exact same thing with the 10-degree angle, the head moves forward, but they only need 200 millimeters. In that case, with the high G, there's a pulse that drives that bottom sled. That pulse has to be complete before that door hits the child. And they can do it in 200 millimeters of travel. So now the head is in a different place. And if one of your pass-fail criteria, which it is in the proposed test, is the head going to hit the door? Because we're trying to protect the head. We want to make sure, because that's the highest risk of injury and side impact for children, that this whole thing of the head, what place it's in, that if you ran it on my facility and I got 800 millimeters of travel, and not only is it moving back, but it's moving back. So I've got the inertia. When it hits, it actually wants to continue backwards. Where on the high G sled, so you go run it at MGA, which is a test house that has a high G sled, they run it, the head's moving forward, and it's still moving forward. It tends to want to roll out of the wing more easily. The whole idea of a standard is that no matter where I run it, that same test should give me the exact same results, no matter where it's done. And right now, with the setup that they have, it doesn't. We tried things, so we had to, under contract. We taped the head, we used Scotch tape, but the whole idea of the 10-degree angle was because we see higher risk of injury if the head is rotating. So in that angle impact, you get head rotation instead of just the lateral motion. So that's why the industry or the government wanted the 10-degree angle. But the 10-degree angle is causing so many issues for the repeatability of the test. So right now, this testing, or the proposal, we still don't have a final rule. We were hoping to have a final rule in December of 2013. You can see they're not there yet. The government, I think, moves slower than any industry I've been in. But hopefully we will have a final rule now by the end of 2015. So some of the things that we learned from it, to get some engineering in here. So this is the setup. You have the primary carriage, which is the door fixture. You've got the child seat in the secondary carriage, and it can slide on the linear bearings to come in and hit the wall. We have in that, we were trying to make sure that the relative velocities between the door and the child, so this is velocity in miles per hour, in time, so the impact takes about 180 milliseconds. So we got three things happening. So the red line is the primary carriage. So it comes in and the primary carriage hits the decelerator. So the whole idea is it needs to stop. So the primary carriage stops, and then the secondary carriage, so the child keeps moving. Now you notice his speed does decrease a little bit. We have friction in the bearings, plus it's coming against that 10-degree angle. It does scrub off some of the speed. So we found, too, we had to change out those bearings every so often, or we were starting to see differences between these relative velocities. So at this point now the child hits the door. You can see our primary carriage does get a little bit of speed just because of the mass hitting it, but our relative velocity in general, which is the green curve, number 3, does pretty well. That's what they're going to then list in the standard, is what does the relative velocity have to be between the child seat and the door in order to run your testing. One of the other things that we found, and I'm talking too slow. One of the other things that we found, it was just a really interesting find, is that in setting this up, if we set the child seat on the fixture the same every time, if I had a wider seat, it would end up getting more energy because there's also, let me pull this up, there's also a block of honeycomb here that's impacted. So if I have a wider child seat, the door strikes the child seat before it strikes the honeycomb. That's taking the energy out of this impact. So they wanted to set it up that the child seat would always be in the same place every time. But if I'm doing a component test and I want to make sure this child seat runs just like any other child seat, then no matter if it's skinny or wide, it should be able to handle the same amount of energy without breaking. The industry is also having an issue with that through the standard. So out of the tests, we did tests on 15 different child seats during this series. Through the skinniest seat and the widest seat, there's a 23% difference in the amount of energy that went into the skinny seat, less energy, than went into the wider seat. The industry is saying, well, I would like to be able to make a skinny seat because a skinny seat in a big car, that I'm going to utilize that as my safety feature. Well, you might also have a skinny seat in a skinny car. So it should be, in my opinion, that we should test every one of them the same. It's the component that's being tested, not the car. So that's another issue that's coming into play in the standard. So there's a lot of questions yet. So another area that we just got into is pet testing. Now, when I first got the call from the industry and they said, yeah, there's something going on, they want to put harnesses on the dogs, and if you got your dog harnessed in the back seat, they're saying that there's an issue with this, that in a collision, because there's no testing of pet harnesses that are used as seat belts on dogs. So I went home, told my husband, I said, yeah, I got this call from the pet industry. And I started getting ribbed about this. Is this what you went into crash safety for? Are you going to be saving dogs? Are you going to get dog dummies now and they're going to have instruments in them? But when you look at it, it really is a critical issue. You got a 150-pound dog sitting in your car unrestrained, and you get into a collision, that dog is flying free. So it's not just the dog, but you put an engine block in the back of your pickup truck that's not properly tied down. You get in an impact and it flies free. Any type of free object in that vehicle is not a good thing. So it's not so much can we protect the dog, because I don't think we're going there. I don't think we're going to end up with dog dummies that have instrumentation and cadaver testing with dogs and all that, but it's can we keep the dog restrained in the test. And is this going to play for me? Come on. There we go. So this was one of the tests. This was one of the harnesses that said it would protect your dog in an impact. And you can see the harness just breaks away. This is a 75-pound dog that we had a tether on him because we didn't want him to go off and break anything else in our lab. So right now, we are working with the industry. We are setting up to try to set up a standard for their testing so that they use the same kind of dog dummy, the same weight, same procedure, everybody running at 30 miles an hour. Right now, the different companies are not quite wanting to work together. They want to get the leg up on somebody else, dog leg up. And so we are just starting to work with this industry, but it really is a critical issue for the safety of the passengers in the car. So if you are out there, you're going to be traveling with your pet during the, anytime this summer or whatever, put them in a harness, put them in a cage, make sure that it's properly restrained in there. Some harnesses are working better than others, and at this time I don't have a full list of them, but we did run some tests for CBC. So I'm going to go through this real quick. I thought this was interesting. It was buckle up every time. It was a survey that the Safe Kids International ran. And it said there's still unbelted kids out there in cars. And they found, why is it that the kids are unbelted? You got all this information, all this education about child seats. And they found these were the biggest reasons. I'm not going so far. I didn't have the booster seat. My wife had it in her car. I picked up the kid from child care. I didn't have the right child seat. I was traveling overnight. The child wanted to sleep. Figured I'd just let him sleep on the seat. Rewarding the child. You don't have to be in your child seat. It's a good thing. It's not a reward. And, or you were holding the child. So they might have been crying, so you figured I'll take them out of their seat and I'll hold them. All not good reasons to have your child unrestrained in there. But they also took and they looked at it by education level, by male and female, by the age of the parents. And one of the things that I found was interesting, males were more likely to let their child be unrestrained. Education level, the more educated they were, if they had postgraduate from college education, the more educated, the more likely they were let their child be unrestrained. And the higher the income, the more likely they were to let their child be unrestrained. So it wasn't the fact they couldn't afford the seat, is that they could. So it was a very interesting study that they ran. So just real quick about airplanes. Now airplanes are an interesting one. You look, you've been on an airplane, you got a lap belt. They don't in any way look like the seats that we have in vehicles. You don't have lap shoulder belts. In the European Union, some overseas flights, the first class have lap shoulder belts in first class. The plane that crashed in San Francisco got caught at the end of the runway and then had the horrible crash. Most of the people survived. The people who had the most critical injuries were those that were in economy class that had only the lap belts. And they had severe internal injuries and spinal injuries from the lap belts. Those that had the lap shoulder belts were in much better shape. The European Union has a rule that says every person in an aircraft must be protected the same way. So they're now saying that why didn't economy class have lap shoulder belts? That they should put them in there. It's going to add the weight of an airplane, so there's big issues with that, because the other thing is what is the real exposure rate? You're much more likely to be in a collision on the roads driving to the airport than being in the air. So, back up real quick. All right. So one of the other issues, though, is children who are under 2 can ride on the lap in an airplane. And that, again, as someone in crash safety, thinks this is a really bad idea. If you're in a crash, your child is free flying, and we don't want that. They can go anywhere. So they say you can bring your child seat on board and you can put it in a seat if there's a seat available. The problem is, when you look at an airplane seat, it doesn't have that angle on the bottom like you do on a seat in a car. So the car bottom has an angle to it, which helps the child seat during the frontal collision. Airplane seat is flat. And the way that the seat belt is routed is not meant to go with a child seat. So in the tests here, they ran their own. CAMI is a medical institute, aerospace medical institute in Oklahoma City. And this is a test with a child seat. And this is very slow. We're talking less than 20 miles an hour. The seat does not stay on the seat. And if you had another airplane seat, which now they're squishing them closer and closer, the seat's going to impact the one in front of it. In fact, one of the other tests that I had found, the child seat gets jammed behind or underneath the seat. So if you're a parent that's in an airplane, you're trying to get out, you can't get your child out of there, you're going to have some issues. Child seats do not work very well at all with airplane seats. But it goes back to that exposure rate. We'd rather have the people fly if you're looking at them driving long distances, because you have greater risk of getting into a collision and injured on the roads. So one of the companies we're working with, though, has a thing called the Baby Bear Flight Vest. So it is a vest like this on the child. It's got all the tethers on here. And the idea is that your lap belt would go in here. And your lap belt would go through here so your child can't go free flying. Now they're approved by the FAA to use this during flight. So in turbulence and everything, and it has worked. Where people have had that on, turbulence, the plane drops, the child wants to stay up because everything else is moving down, and the child doesn't hit the ceiling or hit the roof of the airplane or go flying in any other way. So it has really helped reduce risk of injury. But the company now is asking that why can't we use it in takeoff and landing? So they're looking to see how they can go about getting it approved for takeoff and landing so that it can be used for that time as well. So we've been working with them. Problem is, FAA doesn't have any standard. So we've been looking at how is it, what should it be tested to? Every time we ask them, they say, go figure it out. They don't want it to be in any place to say, yes, it will pass and fail. They want them to try something. So we've been working with them and what would be the best way to address these issues. Lap shoulder belts are now going to be a required law in all coaches. School buses don't have seat belts. People always ask, why do we not have seat belts? A lot of it has to do with the fact, would you want to be the bus driver telling those kids to wear the seat belts all the time? But there are other issues with that too, as far as momentum and energy. The fact that if you do strike something, you're usually not going to have a big change in velocity in a school bus. That's why they pad the back of the schools, the seats of each one, so that if the kids do hit it, that you have a less risk of injury. So, thank you for being here today.